Hey,
Hello.
hey, how are you doing?
Great, great. Can you hear me?
Yeah, I can. Can you hear me?
Also, yeah, awesome. Yeah, I can hear you. Yeah, as well. Yeah.
Great. So, my name is Abanob. What's your name?
My name is Henry.
Henry?
Henry. Yeah.
Yeah, nice to meet you.
Nice to meet you. Okay. This is the first time I'm doing this, so I don't know how to do it. Uh, so,
Uh,
so now I am. So
now,
who is the interviewer? Who is the interviewee?
now you are the interviewer and I'm the interviewer.
Oh,
Now you are the interviewer. So I should
oh,
solve
I
this
am the
problem.
interviewer.
Yeah,
Okay. So you should solve the problem. So can you see the question?
yeah, I can.
So the busiest time in the mall, right?
Yeah, I see. Uh,
Okay,
I will read the problem first and then we'll go through it.
okay.
The Westfield Mall management is trying to figure out what is the busiest moment at the mall was last year. You're given data extracted from the mall's detectors. Each data point is represented as an integer array whose size is 3. The values at indices 0, 1, and 2 are the timestamp, the count of visitors, and whether the visitors entered or exited the mall. 0 for exit and 1 for entrance. Okay, respectively. Here is an example of a data point. I have a timestamp and number of visitors is 4 and 0 is which means exit. Note that time is given in a Unix format called epo, which is a non-negative integer holding the number of seconds, okay, that have elapsed since, okay. Given an array data of data points, write a function, find the busiest period that returns the time at which the mall reached its busiest moment last year. The return value is the timestamp. The return value is the timestamp. Note that if there is more than one period with the same vector peak, with the same visitor peak, return the earliest one. Okay. Assume that the array data is sorted in an ascending order by the timestamp. Explain your solution and analyze its time and space complexities. Let's see this example. We have timestamps here and 14 number of visitors and 1, which means 14, which means 14 visitors in the mall right now because they have entered the mall. And in the next timestamp we have four people and they are going out. So now the mall have 10 people inside. In the third timestamp we have 2 people. Okay. I guess I got the problem, but I will need to recheck if I got it well or not. Uh, can you hear me? Can you hear me?
Yeah.
Great. I was saying I guess I got the problem, but I will need to recheck if I got it well or not. In the beginning, I have data, and it's an array of vectors, and each vectors has or array of array. Each array has 3 integers. The first one is a timestamp, and the second element is the number of visitors, and the third one is uh, if people are entering the mall or exiting from it. For example, here, uh, can you see what I'm writing?
Yes.
Great. Okay. Here in at this time in this timestamp we have 14 people and they are entering the room, which means the room have 14 people right now at this time in this timestamp. Uh, after that,
Mm-hmm.
after that we have 4 people are going out from the mall, so which means I have 10 people
Mm-hmm.
in the mall at this moment.
Mm-hmm.
Uh, After that we have 2 people are going out, which means 8. And here
Mm-hmm.
10 people are entering the room, so it would be 18, because 8 plus 10 is 18.
Mm-hmm.
After that 18 people are
Mm-hmm.
going out, which means 0. And here 18 people are entering the mall, which means 18. After that 1 will go out, 17. And here 7 will enter, which means 24. And here we have 7 will go out, which means 17 here. So I guess the output would be uh, mm, mm, mm.
No,
do I
I think you need to consolidate the time first.
I think the time is sorted or not?
You need to consolidate the time. Actually, let's say the 25, right? So and 25 you end up with 8, and then the 87 you end up with 18, right? And 13, this one you end up with 17, and 11 you end up with another 17. So that's why the answer is this time. So this 78. So this will be the output.
But why it's not this timestamp? Because here we have 24.
Oh, that is because you see these two have the same timestamp. Actually, these two actually the order doesn't matter. So this is just the interim states. So you should consider at the end of that second how many people is still inside. You
Uh,
shouldn't consider the interim state,
oh,
right?
uh, let me think. But here
You,
we
you
have,
know you know what I mean. Let's say it could be something like this. It could be this, right? So you get 70 people in by 70 people out. So at that second, actually, so you should consolidate it according to the timestamp.
yeah, but just a second, like here we have 17 people are in the room, and here we have
Yeah.
70 people will go into the room, so we will have
No, no,
okay, so
let's use 7. Yeah, just use the 7. Yeah.
okay,
No, there's not 24. 24 is just the interim result. You know what I mean?
yeah,
It's not a final.
yeah, like 7 people at this time stamp, 7 people are going in the mall, so in the mall now we have 24 people there.
No, no,
uh,
no, no, no. You can do something like this.
okay,
You can say something like this.
uh,
You know what I mean?
yeah, now people will be 10 here,
Yeah,
and here 17.
yeah.
What I got from the problem is we have this number of people at this timestamp. Is that right? Like here at this timestamp, we have 17 people in the mall. Is that right?
Here you have 18, right? You have 18. Yeah. So you need to find out the maximum number. Minimum is 18, and the corresponding timestamp is this.
Yeah, but they have said that if there are more equal, like here we have 18 and here we have 18, I should take this one, I guess. Yeah, uh yeah, it's this one, by the way. This is the answer, I guess.
Yeah.
Okay. Just one thing before I go through the algorithm. These timestamps are sorted, or should I go through them by this order, or should I sort them? Uh,
Yeah. No, it's already sorted, right?
yeah, great. Okay. So at each, my algorithm will go through this array, and then I will know how many people in the mall at this timestamp. Like here we have 14, so this is the maximum timestamp, or this is the maximum number of people at this timestamp. We have 14, and 14 relates to this timestamp, and I will go through the data till I find a number of people which is bigger than this one. If there is, I will make the maximum timestamp is the new one. Yeah, this is my algorithm actually. Like going through the data and know how many. I just like number of people will map to timestamp. When the number of people is bigger, I will return its the mapped or the corresponding timestamp. Okay. Yeah, I think this would be my algorithm to go through each array and calculate the current number of people, and after that we will map it to a timestamp, and then we have this time and then we have this number of people and we have this timestamp, and like here we have number of people is 14, and it's the timestamp is this one. Yeah, when I get maximum when I get like here we have okay, we will go through the other data. Here we have after calculating the number of people in the mall, we will see that it's 10, and 10 it is not bigger than the current number of people, which is 14. So I will not do anything here. I will continue till I find 18. When I find 18, I know that 18 is bigger than the number of people, or the current max number of people, which is 14. So in this case it would be 18, and I will map it to the new timestamp, and we'll do that till the end of the array. Is that right? Do I get the problem well?
Yeah.
Great. So this would be
Yeah,
my
I think that's correct.
great. This would be my algorithm. The time complexity of this approach, it would be. I will need to go through the whole data. So it would be dot time. It's O of n. N multiplied n. We can say n multiplied 3 because n the number of rows and 3 is the number of columns, which is guaranteed that they are 3. So this would be my time complexity, and the space is O of 1 because I'm not using any other data structure. Do you have any comments on time complexity and space complexity?
Yeah, I think you are correct.
Great. So should I code my
Yeah,
algorithm?
and yeah, just code I think code your algorithm. Yeah,
Great. I'll code
just
it.
implement your algorithm. Yeah.
Great. In the beginning, I will have number of people, like current max people, which is 0, and then I have n current max timestamp, or we can say it's max number of people and max timestamp, which is equal 0, for example. I'll go through the array. Before that, we can say int n to store the data size, and here in this for loop int I equal 0 I. Okay. N people int n people will equal to data of I of its timestamp. This is the current timestamp, which is the first element in the array, and then int num people or n people, which is data of I of 1. After that we have 0 or 1 to determine the current number of people in the mole. So we will detect like int n enter or exit, which is equal to data of I of 2. If it's enter, we can call it just enter. Okay, if enter is not equal 0, which means 1, so in this case we know that people are gonna go into the mole, so we can say int current people in mole. Current number of people in the moon will equal to I guess this variable should be outside the loop because it will be a dependent variable, like it will change each time. So here, yeah, if it's enter, so I should add the current number of people to this variable, so plus equal n people. Otherwise I will remove it from this variable. Equal. Okay. Okay, after doing this we know that current people in mole is I should work on this variable because my output will be related to it. Okay, so yeah, I will compare current people in mole to this variable, which is max number of people. Like if current number of people is bigger than the maximum number in mole, in this case we know that this would be the maximum number of people, and we know also this would be the corresponding timestamp should be the maximum one. So in the end I should return the maximum timestamp, max timestamp. I guess this would be my approach, but I will need to go through the code quickly. In the beginning I have max number of people and max timestamp n, which is the size, current number of people. Okay, I'm going through the array of data in timestamp. Okay, here the timestamp, the number of people, enter, which is to know if people are going in or going out. If enter is true or if enter is 1, we know that I will add the current number of people. If no, I will remove it, and then I'm comparing the current number of people to the maximum number. If it's bigger, I know that maximum number of people will equal to current and max timestamp. Okay, I guess this would be my approach. Should I run my
Yeah, you can write.
Okay.
Maybe you need to call your code. I'm not sure how the test working. I never used this before. Have you ever used this before?
Yeah, I have used it a lot before. So just
Call it.
yeah, below, like on the bottom of the screen, you will see run code and run tests. I don't know if it's in your screen or not, but it's here. I have clicked on run tests, but I see that there is like 2 failed test cases. Okay.
2 failed test cases. Oh, failed 2. I see.
Yeah.
Passed 4, failed 2.
Yeah, I'm gonna think of what's the problem. Okay. By the way, I can like I'm gonna do something to make the code more cleaner regarding this two condition. Here we have this. Uh, yeah, plus equal if enter. Yeah, I will add it to me. Otherwise I will like delete it. You know what I mean?
Yeah.
Just run this to see if yeah, it's the same. Okay. Okay, if there are more timestamps, or if there are like two equal max number of people, I think I'm handling this test case. Like if there is 18 and after that I found 18, like 18 people in the mall, I guess I'm handling it well. Okay. Okay.
And I said you need to consolidate the timestamp because the timestamp are duplicate.
I should do what? Sorry.
Consolidate the timestamp.
Consolidate. I don't know what I mean, to be honest. Can you explain it?
Because you say the timestamp are the same, right? For the timestamp could be duplicate.
Here I'm not caring about the timestamp actually. I'm just caring about the maximum number of people, and after that I'm getting the corresponding maximum timestamp or the corresponding timestamp and add it to this variable.
Okay. So you need to pay attention to that there could be multiple data points with the same timestamp. You know what I mean? So the mall has multiple entrances, and the visitors could be entering the visitors could be entering and exiting at the different areas of the mall at the same time. So let's say it has multiple entrances, right? So your calculation method is wrong because it could have multiple entrances.
I think I got your point right now. For example, here just examples, the given example, we have like the first two rows we have the same timestamp. Okay, we have the same timestamp, and we should calculate the current number of people after all these. I mean, at this timestamp, after all the people that will go out. And
If there's the first three rows has the same timestamp, and that means that the people enter and exit and a different area. So there could be multiple entrances or multiple exits, right?
yeah, I get your point. And also the current number of people is not dependent in different timestamps. Is that right? Like here, the first three rows, the number of people in the room are in the mall are depend. This variable is dependent because here.
Yeah.
But after that, the number of people in the mall is not dependent. I think I didn't get the problem.
Yeah, that's why I said you need to consolidate the timestamp according to the timestamp.
I get your point right now. Okay. Okay.
Yeah, this is important since data points with the same timestamp clearly cannot be regarded as different period in algorithm. You are regarding them as different period.
Exactly.
But
yeah.
Actually they are not.
Yeah.
They're the same time, but there's different entrance. Maybe you can consider them as different entrance.
Yeah, that's what I'm doing actually. Yeah, thank you. I'm thinking of so this condition, it will be at the end of the current at the end of the timestamp. Okay, so here like okay, I should compare the current timestamp to the next one to see if it would be a different timestamp or not, and from here we can go and change. Okay, if the current timestamp, let's assume that I is less than n negative 1, because I'm gonna compare it to the next one. If the current timestamp is not if the current timestamp is equal to the next one, which means data of I plus 1 of 0. In this case, we know that they are the same. So yeah, I'm gonna do this. If not, okay, so for example, if not, I should get this I should do this condition. Okay, and also like here in the third row, we know that the next timestamp is different, so I'm gonna get the maximum, and I should make the current number of people is equal 0. And
why?
Because after that we are gonna calculate a different I mean current number of people in mole will be 0, because in different timestamps we will start from the beginning, like it's 0, and I will calculate it in the timestamp. You got what I mean?
I don't know why it becomes 0.
I mean like
That's
this.
a different timestamp.
Yeah, but I didn't reach it yet. I mean like here I'm just comparing the current timestamp to the next one. If the current timestamp is the same as the next one, we know that we are in the same timestamp, and I will calculate the current number of people. But if the next
Okay.
yeah, okay, so current number people will be 0, and current and the timestamp, yeah, that's it. Okay. Okay, so and the first timestamp it's the same as the, okay, so I will calculate it. It's the same, but what if it's different? But if it's different, actually I'm not I should do it do this as well, like here. Yeah, because let's assume that the first in the given example, the first timestamp is different than the second one. So here I'm comparing the current timestamp to the next one, and I see that they are not equal. I'll go here, and I should calculate it. Calculate the current number of people. After calculating it, I will get the maximum and reinitializing it to 0. I guess that should work actually. Yeah. So we
can try it.
Okay. Oh. What? Okay.
Why you need to do this current people in mole equals 0? Why you need why did suddenly become 0?
Because here, like,
Why?
you can see, let's assume I'm in the third row, which means like let's assume I is equal to 2 now, okay, in this loop. I is equal to, and we have the given example, okay. So if I equal 2, we have the third row, and we have this timestamp which ends with 24. I'm gonna compare here. I'm gonna compare the current timestamp to the next one, okay. We know that they are not equals.
Yeah, if it's different, if it's different, why you reset the current people in more equal 0?
Yeah, they are different. So here I'm gonna here I'm gonna calculate the current number of people, and then is the number of I think it's
You don't have to do this.
yeah, that's what I think I got you now. I was just initializing it to 0 to
Then you,
yeah.
then you,
Yeah, it's paused now. I guess it's something I didn't get it well. Like I thought, I was thinking that I will deal with each timestamp in a different way. Like at this timestamp, calculate the current number of people in the mode, and that's it
I
for this
don't understand
timestamp.
why you want to do that.
And when going to another timestamp, so I will make the current number of people in the mode 0, and start from the beginning. So that's why I've made it like that. But yeah, it is not right. Yeah, that's it, I guess. Do you have any comments right now on this code, or we can discuss the feedback later?
I think you can do some optimization, right? These two lines of code are the same, right? So you can move it here, right? You don't have to do this, right? Don't
Yeah,
have to do this, right?
I gotcha. And here I'm gonna okay. Oh, okay. Uh, but here, if they are not equal,
And then you need to change this.
yeah. Uh,
Yeah,
yeah, it's working.
yeah.
Thanks.
Yeah, no problem.
Okay.
So shall we swap roles?
Yeah, now we can swap the rules and discuss the feedback later.
Okay. Okay,
Okay.
now I already swap roles. So now I am the interviewee now, right?
Yeah, exactly.
This is the first time I do this. Sorry if I. Okay, so now I'm reading the. Let me read the question. So, given an array of unique non-negative integer implement a function, get different numbers and find the smallest non-negative integer. This is that is not in the array. Um, Even if your programming language just doesn't have this restriction, like Python, assume that the maximum value is int max. Okay, so if, for instance, 2 raised to the power of 31 minus 1, for instance, the operation max int plus 1 will be undefined in our case. So your algorithm should be efficient, both from a time and a space complexity perspectives. Solve first for the case where you're not allowed to modify the input array. So if successful and still have time, see if you can come up with an algorithm with an improved space complexity when modifying array is allowed. Do so without trading off the time complexity. Analyze the time and space complexity of your algorithm. Okay, so this is 0, 1, 2, 3. So output is 4. So unique non-negative integer implement function. Find the smallest non-negative integer that's not in the array. Okay, so interesting. So if it's let me think. So get different number. So it has 0, 1, 2, 3. So the smallest non-negative is
Four.
smallest non-negative is 0, 1, 2, 3. Then it would be 4. Right? So but this how about if this? How about if it's a unique you leave non-negative integer, and let's say to 4, right? Then that the result will be 1, right?
Yeah, exactly.
Because you don't know. Yeah, because actually this could be unsorted. So let's say how about we sort this array. Let's say if we sort this array, it becomes 0, 2, 3, 4. In that case, I just need to check of one by one. I just need to check if I just need to loop and see if one is inside. So you should be, yeah. I just need to sort this array, I think.
And what are you gonna do after sorting
Uh,
it? No,
I just need to sort
no,
this
no,
array.
don't write the code now. Just let's discuss the
Okay.
algorithm. Like,
So just look, I just need to sort this array, right? And then I do a for loop. For loop, and I check the index and the value, right? So if it is a 0, 1, 2, 3, so then if I loop it, then I will get the array's index, right, will equal the value, right? So if it is not, so if it is not equal, then I return, then I return, I, right? So
yeah, that.
that is one way. I think another way is
But
yeah.
but
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 let me do this.
but
Hmm?
what is the time complexity and space complexity of your solution?
Yeah, the time complexity was the time complexity will be log and log, and the space complexity will O1. Yeah,
Okay, so
just say
can you optimize the time complexity?
provide what data time complexity.
Yeah, can you improve
You
it?
mean that?
Yeah, can you improve it?
Yeah, I think I can do a better complexity, but I think I can do a better complexity, but let me do this implement this simple one first,
Okay,
and I will do a better one later.
okay.
So if a I and not equal to I, then return I. Uh, otherwise return return ARR the size plus 1. Oh, no, we don't return this. Let me try to run this.
Don't forget that
What?
the given array is constant, so you can't change it.
Oh, yeah, I cannot change this array. I see. I cannot change this array. Okay. Hold on. Let me think of it. Oh, then I don't. I cannot sort it then. In that case, then I can put them into a bucket. Let me think. If I cannot sort it, right? So if I can sort it, then it will be. I think then it will be done. But now I cannot sort it, and yeah. So. Mm, I see. So I can do the swap. So if this is not, so I can do a swap. I can do something like this. If AI is not this, I will use another one. Let's say T equal
What are you gonna do?
ARR RRI, and I'm going to do ARR. This arrays index, right? So this index.
Like, what are you gonna do here? What are you trying to
I
do?
am just Oh, I cannot adjust this. I cannot change this array. Okay.
Yeah,
Then
so
in that case, I think I need another. Yeah, I cannot change this array. Then I need another array.
regarding your
Yeah, that
solution,
means I need another.
yeah, regarding your solution when you were talk about using sort, you can just like make a copy of this array in another array and use it. But
Yeah,
here,
make a copy. Yeah, I can use another array. Yeah, I can use a.
yeah,
Uh, yeah, I can use another array, but but this space complexity uh, will be r. Sorry, n will be n.
yeah,
Yeah,
we can
maybe something.
will improve the time and space later.
Sorry.
Bless you.
Yeah, sorry. And then I do this. So if this is not equal, then return a I. No, it return I. The smallest, right? Return the smallest. Find the smallest non-negative integer. Yeah. Otherwise, we return this. I think now it should work.
You can run the test.
Finished executing code, but then click run test. Oh, recommend you okay. After I sure you are ready to test your okay. I'm ready to test my code.
Yeah,
Okay, so this passed. So this time complexity. Yeah, so this is an organ. Yeah, and the space complexity is n.
great.
Yeah.
Can you
Uh,
optimize time complexity?
can you input time complexity, right? Input time complexity. I can do something like this. Um, I don't have to sort it. So if this AI not equal to let me think. This is then we move uh we move this uh AI.
Before going to implement the code, can you tell me about your approach?
That means we move this number. Actually, my approach is ideally every number should be at the correct place where AI should equal I, right? So, but if it is not, then that means it is not an ideal position, and then we want to adjust it to ideal position. Uh, and uh, and then we want to adjust that. But in that case, this AI. So how about this AI? So this one will be affect. This AI is the if this is not equal to I, and we know AI will be
Can you think of using another data structure, like just get rid of this vector and use another data structure can help you in this problem? Can you think of data structure will help you here?
uh, maybe use a bucket.
Uh, like which data structure you mean?
I mean, just another linear data structure, just like a bucket, right? Like a bucket. like a bucket, and the size of the bucket is the size of the array. So
When you say packet, you mean like an array, another array?
array, yeah, another array, yeah,
But I think
something.
the array will not be helpful here, like, because for example, if you have an array, you have an array like this, like, uh, if you're doing something like this here, I think it
Yeah,
will not be
yeah,
helpful.
that.
This will not work here. So think of another data
Mm,
structure can help you, like, think of another data structure, the searching in it is O of 1.
and that is a hash table.
Exactly, but what
Yeah,
what what is the
we
other,
can use
what is the other data structure
we
that,
can use a hash table.
okay, okay,
Maybe a set, maybe a set, maybe a tree set.
exactly, you mean a hash set, or a or a set, just a set?
Yeah, just as um. Let me think. If we use a hash table, but the hash table is unsorted. Oh yeah, but we can also we can use a hash table.
Yeah,
We can use a unordered map.
yeah, it's working here,
No,
but
map.
what would be the key and value?
The key will be the the key will be the array. Yeah, the array number element, and the value maybe just use the unordered set. I think.
Exactly, exactly.
Yeah, unordered set maybe should be fine.
Yeah, great.
Uh, yeah, to use unordered set,
Yeah,
and then maybe we can initialize it as R begin and end. Yeah, so on the set, then we will do this. So if uh, so if US contains I, not contain I.
it's count.
Yeah, then in C++ 17 you can use contain.
Okay.
Yeah, you can use count as well, but count will count will loop through all the set. But contain will just when it find it, it just return. A count will.
Yeah, great. I got you.
Yeah, yeah, yeah. Yeah, if so yeah, that's anyway. So in this case, it will be on. Yeah, so the time complete will be on.
Yeah, great. Just try to run the tests here.
Okay. Oh, run test case. Okay. You say undeclared unordered set. Okay, we need to declare this. Unordered set.
Yeah,
I think there's no contain because this is not a C++ 11 17.
yeah,
This is
yeah. Great job. Well done.
yeah. From normally this account 0. Yes, it seems okay. So this is time complexity n, space complexity n. Yeah.
Yeah, I see. That works well, actually. Good job.
But the question said solve the first. You are not allowed to modify. If successful, and will have time. See if you can come up with an algorithm with improve the same space complexity when modifying is allowed. Let's say if we can modify it, right? So if we can modify it, let's say if we can modify it, I think if we can modify it, just do the same thing like this. Vector E, right? So I think there's some way to do it if we I just forget how to do that. So for this, I think it will be something like this. While there's a while loop. Yeah, while a I is not equal to I, and then we will do AAR RI equal I, and ARR I equal I. Something like this. I think we should do this
But
until
we've said I think it will not be working here because it just have two elements, so it will give you, I guess, runtime error here or out of bounds.
yeah, you are correct. So if this one, if ARR I less than ARR dot size, we'll do this, and I think this will be T equal AAR I, and there will be equal to T. Let me see. T equal AAR, and this.
I don't understand what are you trying to do actually. Can you tell me?
That said, I want to adjust that.
But I guess
And
you got the optimized solution before, so
okay, for example, okay, so in this case, right, and let's say if this is 0, 2, 3, 4, right? So okay, so first one I will come here, and then when I come here, so I find this AI not equal to this, right? And then I will so in this case, AAR this will still be 2, and this one will become 2. Actually, I should put this. I should put this. I should put so this should be equal to this. You see now this will become 2, and this will become
I guess
actually this.
I guess swapping the elements is not working here. I don't know, but I guess it's not working here.
Why? Should something equal like this. Yeah, but I think in this case, I mean, I want to reduce this this complexity to 1. I think, you know, and after I do this, right? So then I will do this again for I equals 0, I this size and I plus plus. Then I will do if AAR
I think I got your point. I got it.
not to I, then return I. Yeah, but it might not work.
Mm,
Look at this. Read only. Okay, so not AR. This is A.
A.
I should use this. A. A. Yeah. Like this. Field once. Like this. That makes yeah, and because you say see if you can come up with algorithm. I think there must be some way you can do it with linear with constant space.
You mean if you consider that this vector is not constant, it would be O of 1? I like your solution actually.
Yeah.
I like it. Like, but there's a field case. I don't know what is the problem. Like 0541 expected 7.
Okay, maybe I okay, and then this two you switch this to this, and then I go to the next one, and the 0. I go to the next one, 3, then 2, and then 4. I will switch. Hold on. Then I find that this is 4. Then down work, and then I see. Yeah, I should switch this to here. Yeah, I think my algorithm have something wrong. And also, this is how about this? This is 0. Yeah, and you said if there's a one, let's say if there's a 100,000, right? So I cannot do that. Uh, so I need to have everything. Yeah, it's not easy. It's not easy. Yeah, I don't know how to do it actually. I don't know how to reduce space complexity to 01.
I think your solution here is the approach is right, but instead of just two conditions, you will need to like making a while loop inside the for loop and do swapping. But it's the same as your
Yeah,
approach, but it will be like two loops inside.
yeah,
But it's a good one actually. You did good job.
yeah. Thank you. I think we are running out of time.
Uh, yeah, we can discuss feedback now. Like I will start because your problem is here. First thing is, I see you did great job and you discussed the time complexities and write clean code. But I think in the beginning you jumped into the code quickly. Maybe you will need to take your time explaining your approach to the interviewer. It would be better, I guess.
Mm,
The interviewer wanna see the approach itself and your way of thinking. So before just jumping to the code. So
mm,
this one thing. Uh, I guess
makes sense.
I guess I don't have anything else. Uh, because you did great job. We can swap the rules and
Thank you.
you can tell me about your feedback on my code and my approaches.
I think you need. I think you also did a great job. But the thing you can improve is to, I mean, uh, grasp the hint from the interviewer quickly. Yeah, earlier. Yeah, consider the hint like this. Uh, yeah, I mean the consolidate is according to the timestamp. Consolidate the input according to the timestamp. Yeah. So,
Yeah, you,
but
you
the rest are good. Yeah.
you're right at this point. I think
Mm.
you've said it a lot, but maybe I didn't get it. That's why I messed it up. So what about the
Yeah.
code itself and the naming and
Yeah,
discussing?
the code is great. I think the naming convention is good, but it seems to me this seems more like a Java's naming convention. Right? C++. I also don't know. Your naming convention is very good. Yeah, it's like a production code. I think
Yeah,
that's also and also one of the good one of the good things. Yeah.
great.
Uh,
Thank you so much